Don't know much about algebra. Don't know what a sliding rule is for. But I do know one and one is two. And this one could be with you. What a wonderful world this would be.
Hey everybody, welcome back to Mr. K's 30 Minutes of Math. I hope you are all doing well, and I am excited to get started today. Let's make sure we got our video going. There it is. Hey everybody, I hope you had a great weekend. I hope you got a little bit of time outside with the warm weather and maybe got to take a walk or maybe ride a bike or do some hiking or just anything to get outside and move around. I know it's a difficult time where we're spending so much time indoors and so many things we can't do. Hopefully, if you do have some safe space outside to enjoy, you're able to do that. All right, let's get started. Let me bring up our riddle from last week. So let's get this going. 1 second, folks, and I think we should be good to go. All right, here it was, and I'm gonna turn off the video so I can just focus on the riddle. Okay, we had these triangles with numbers on the corners, or in math we call these vertices. One of them is called a vertex, and more than one is called vertices. Cool word. Okay, so you'll see here we had in this first one 3, 3, and 5, and then there's a number in the middle, 11. And there's some relationship between the numbers on the outside and the number in the middle. And the question is, can you figure out from all of these what the relationship is such that you can then fill in what goes in this one right here? So let's take a look at each of these real quick, starting with this first one. We have 3, 3, 5, and 11. So 3, 3, 5, and somehow those numbers are related to 11. Well, it might jump out at you that if we added up those numbers, 3 plus 3 is 6, and 6 plus 5 equals 11. Aha! If that didn't occur to you right away, that's no problem. It takes a little bit of time to think these through. All right, so that helps us understand this one. Let's go to the next one. I'm going to erase this stuff right here. All right, let's try the same thing. We have 6, 2, 1, and the number inside is 3. All right, 6 plus 2 is 8, and 8 plus 1 equals 9. Uh-oh, 9 is not 3. So that does not work for that one. All right, let's come back to that one. Let's see about this one. All right, we have 12, 0, and 2, and then the number inside is 14. Let's try it out. 12 plus 0 equals 12. And then 12 plus 2 equals 14. Aha, that one worked. Okay, so let's try the last one. 5, 1, and 4. All right, 5, 1, 4, and then 0 is in the middle. Does this one work? 5 plus 1 plus 4, we know that's 6. Plus 4 equals 10. 10 and 0. Nope, that one does not work. Okay, well, we know 2 of them worked, and interestingly, those are both purple triangles. So maybe there's one pattern for the purple triangles and a different pattern for the red triangles. Whoops, let me put that back. All right, let's look at the red ones then. 6, 2, 1 to get 3. And it might have occurred to you if you stared at it long enough that instead of adding, maybe we could subtract. So let's see, 6 minus 2 equals 4, and 4 minus 1 equals 3. Aha, that does work. Let's see if it works for the other red one right here. Whoops, let me put that back. Let's try this one. 5, 1, and 4, and 0 was in the middle. 5 minus 1 equals 4, and 4 minus 4 equals 0. Aha, so it does work. So that's the pattern. We add the numbers for the purple triangles, and we subtract for the red triangles. All right, well, we know that we have a red triangle down here. So 9, 4, and 3. And the question is, what will go in the middle? Well, let's do it. 9 minus 4 equals 5. 5 minus 3 equals 2. So there you have it. 2 is what should go. Oop, let me do that in yellow so you can see it. 2 is what would go in that triangle. If you got that, congratulations. And even if you didn't get it, but you worked really hard and you tried out lots of solutions, I'm giving you applause as well. All right, let's dive into our fraction work for today. This was your homework, and I'm sure you all did it very studiously. But if not, we'll take a minute here to go over a couple of these. As you can remember, we've been doing lots of decomposition, that's breaking up fractions, but now we're going to do composition, that is putting them together. So we have the directions. Compose the shaded fractions into larger fractional units. Express the equivalent fractions in a number sentence using division. Okay, so let's look at these. I'll start with A. Let's go with that. Let's start with just understanding what we have right now. So how many equal pieces do we have? 1, 2, 3, 4, 5, 6. And how many of them are shaded? 2. So right now we have 2/6. And we want to compose the shaded fraction into a larger fractional unit. So right now our unit is 1/6 or sixths, and we want to compose it into a larger unit. Okay, so the way we're going to do that is instead of creating rows like we were doing for decomposition, we're going to remove rows. So we're going to get rid of this line right here so that instead of having 6 pieces as we had at the start, so let me get rid of this. We're going to have how many pieces? Let's see what we've got. Now, without that line, we have 1 here shaded, 2, and 3. It would look like this without that line in the middle. So now how many equal pieces do we have? 1, 2, 3. So now we're talking about thirds, and how many of those are shaded? 1, 2/6 equals 1/3. But we're not done, because remember, we had to show it in a number sentence using division. So 2/6 is the same as, now we know it's going to turn out to be 1/3 based upon our drawing. Now remember, when we were decomposing fractions, we multiplied because we were increasing the number of units that we have. But now we are decreasing, and so 2 divided by, that's what we're going to do, divide. And we went from 2 rows, remember, here's row 1 and row 2, down to 1 row. So we're dividing by 2, that's why. And that gives us 2 divided by 2 equals 1, and 6 divided by 2 equals 3. That gives us 1/3. Let's do one more of those. Let me get rid of all this work here. Okay, let's do D, this one, which looks kind of complicated. Let's see if I can get this back. Okay, Again, we got to start with what we already have, and we know how many pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pieces, and 2 of them are shaded. So we have 2 twelfths. 2 twelfths. All right, but we want to compose this to go from twelfths into a larger fractional unit. And the way we're going to do that is get rid of this line. So we're collapsing 2 rows, row 1 and row 2, into just 1 row. So it's going to look like this. I know my drawing isn't perfect, but you get the idea. Okay, because we got rid of that line in the middle, so we went down from 2 rows down to just 1 row. How many pieces do we have now? Well, 1, 2, 3, 4, 5, 6. And how many are shaded? That's right, just 1. So there you have it, 1/6. But again, we have to show this with our number sentence using division. Now remember, we went from 2 rows down to 1, so we have to divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And there you have it. So when we are composing our fractions, we can divide. When we're decomposing, we use multiplication. Okay, let us move on. Here, similar work, but now a little bit more is shaded. So here's what I'm going to actually have you do. I'm going to have you try C and D on your own right now. Again, the goal is to, the goal is to compose these into larger fractional units, right? So in this one, we started with 6ths, and here they are. It was 1, 2, 3, 4, 5, 6. But then we composed this by getting rid of the line which created the rows. And what we were left with is not 6 pieces, but rather 3 pieces, with 2 of them shaded. And so what we're left with at the end is not 6ths, but thirds. And thirds are larger fractional units than 6ths, right? Because this is a third of the whole, but this is the 6th. So we're composing the thirds into 6ths. All right, I want you to do the same thing, but try that with C and D, and I'll give you a little bit of music. Today we have, let's see, what did I pull down? The overture to Mozart's The Magic Flute, which is a really beautiful opera. Here you go. Okay, welcome back, everybody. Let's see how it went. Let's start with C. I think I'm going to use green this time. Let's start with how many units we have. So we know what fractional unit are we starting with? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know we're starting with ninths. And how many of our ninths are shaded in? Well, if we count them up, we see that there are 6 ninths already shaded in. But we want to compose our ninths into a larger fractional unit. And I am excited to compose this into, I'm gonna say maybe thirds, because if you look, we could do 1/3, 2/3, 3/3. Now the way we're gonna do that though is we have to get rid of this line and get rid of this line. So instead of having 3 rows, there's row 1, row 2, row 3, what we're gonna end up with is something that looks like this with only 1 row. And so then what we would have is 3 pieces, 3 equal pieces. One of them is shaded, so that would be 1/3. 6 ninths equals 1/3. But we got to show it in a number sentence too. So 6 ninths, we know it equals 1/3 from our area drawing. We went from 3 rows down to 1, so we are dividing by 3. And so, oh, I did, huge mistake. My apologies, friends. And some of you pointed out, that should be a 2. Oh my, please forgive me, moving too fast. We have 2/3 shaded, and we would have another one right here. There you go. See, even teachers make mistakes sometimes. Thank you for pointing that out. And so there you go. 6 divided by 3 is 2. 2/3, which should make sense because if we go back to our original drawing, how many of these sections did we have? We had 2 of them, 2/3. All right, let's do D as well. Let me erase all of this. Okay, almost there. Okay, so D, we started with how many pieces? So we know our fractional unit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, we started with 15ths. And how many were shaded? 9 of them, all of these. Okay, 9 15ths. Now, we're going to compose 15ths into a larger fractional unit. And we're going to do that by getting rid of these lines, which means we're getting rid of these rows. This line's going away and this line's going away. So instead of having 1, 2, 3 rows, we're going to wind up with just 1 row. And this piece is shaded, this piece is shaded, and this piece is shaded. So that matches up with this, this, and that. So now, instead of having 15ths, we have 1, 2, 3, 4, 5 pieces, which means we have fifths. And how many of them are shaded? 3 of them. 1, 2, 3. So 9/15 equals 3/5. Another way of doing this, remember, is with our division. Now we had 3 rows. We went down to 1 row. So we're going to divide by 3. 9 divided by 3 equals 3. 15 divided by 3 equals 5. And voila, there you have it. All right, it is now time, ladies and gentlemen, for our math joke of the day. So here it is. How do you stay warm in just about any room? All right, I'll give you a little bit of time to think. Okay, let's see if you got it. Here it is. Just move to the corner where it's almost always 90 degrees. All right, if you're not exactly sure what that means, if you haven't done geometry yet or you're not feeling as strong on your fractions, that is okay. I'm going to do a little bit of explaining. So, whoops, didn't mean to do that. Let's get some white space. Let's talk about, well, first of all, let's draw, pretend this is a room, and we're looking at it from above. So let's say you're sitting on a drone looking down on your room, and let's pretend there's a bed here, and maybe you've got a green pillow on your bed and a yellow pillow on your bed. And maybe there's a little red table next to your bed. Okay, so we're looking down on the room. And what you'll notice is in most apartments, houses, most rooms, they are perfect L corners. Now that, whoop, didn't mean to do that. Now the L may be turned around, maybe upside down when you're viewing it from above, but they're all perfect L's. And those are called right angles, right angles. Now, right angles are really special because they are what's called 90 degrees, and that's the joke, 90 degrees. Now, the joke was talking about being really warm 90 degrees, but we use degrees also to tell us how big an angle is. And when I mean big, I mean here's a tiny angle. And what we're talking about is the distance between the two parts of the angle, right there. That would be a small angle. This would be a somewhat bigger angle. And they can keep getting bigger. Bigger. Now this is a right angle. A right angle, that's what we're talking about in the drawing. So we start at 0 degrees. That would just be a flat line. And then we get bigger and bigger and bigger, all the way to here would be 90 degrees. And if you remember, everything from one of our earlier lessons, everything up to 90 degrees is called an acute angle. And if you go between 90 degrees and 180 degrees, it's called an obtuse angle. So let me show you some obtuse angles. This would be obtuse. So remember, this is 90. Now, if we want to get bigger, we would do something like this. That would be, I don't know, maybe 120 and bigger until you just have a flat line and that would be 180 degrees. So all of the corners in a room, in most rooms, now there are some strange rooms that are shaped a little bit differently, but most of them are 90 degrees. And so we're making a joke, 90 degrees is for angles, but it can also be for temperature. One more thing I just want to show you that I thought was pretty cool. This is a compass rose to tell us direction. So we have north, south, east, and west. And if you ever have done any work where you use a compass to hike somewhere, or if you're really into airplanes and you like to learn about how they navigate, lots of different folks use this compass rose with these degrees on the side to help them go in the right direction. Now, we just talked about 90 degrees, and look, that's our right angle right there, okay? Now, sometimes when you are traveling, particularly this comes up on airplanes, you'll notice that you'll get directions in a certain number of degrees. So instead of saying go east, you could say go 90 degrees. Or instead of saying north, you could say go to 0 degrees. And this is something you can see if you have ever flown, or if you have seen airplanes in movies, or visited an airport, or you know somebody who's gone on a plane. What you'll see sometimes on runways is a number on the runway. Can you guys see that? That's at the beginning of the runway where a plane will take off. This one says 15, 15. And that number refers to the direction that the runway is heading. So actually, if we go back, 15, and I'm gonna clear this off, 15 is right here. And when we talk, one clarification, when we talk about the numbers on runways, you actually add a 0, so we'd be talking about 150. And so that runway would be pointing somewhere between south and east, sort of south, southeast. And what's really cool is for every airport in the world, even Richmond, there's a map that you can download that shows the runways. And let me show you a close-up view. Here is the Richmond runway. Here's the terminal. This is where you would go to get your ticket. And then here's the runway. And if you see way at the bottom here, I know it's hard to see, there's a 2. So remember, for runways, we're going to add the 0 because they don't have enough space to put the 0. That means this runway is at 20 degrees. And so if we go back to our compass rose, 20 degrees is right about here. So this is north and this is east. So that runway is headed north-northeast, mostly north, a little bit east. So there you go. Cool thing, if you're ever visiting airports, you can look at the numbers on the runways and see what they are telling us. All right. Oh my gosh, I spent a lot of time on that. I apologize. I do want to give you a little bit of homework before we go. And then I want to make sure that we leave with our riddle of the day. So here's tonight's homework. I would like you to use 1236, and I want you to compose it in 3 different ways. 3 different ways. I'm gonna do one, and then I'd like to see if you could come up with 3 other ways to do it. So let's start 1236. So let's say if I did it like this. And let's say I set it up like this. I'm going to start, this will be the simplest way. I'm going to have 2 rows and I need 36 pieces. So that means I'm going to need 18 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. That means we have 36 pieces here, and 12 of them are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to compose this. We're going to go from 36 into something larger, a larger fractional unit. I'm going to do that by getting rid of this line so that we go from 2 rows into 1 row. And so then what we're going to have is how many pieces? 1 shaded, 2 shaded, 3 shaded, 4 shaded, 5 shaded, 6 shaded. Okay, so 12/36 is the same as 6/18. Remember, we have 18ths once we get rid of that line. You can also show that, remember, through our division, we went from 2 rows, row 1 and row 2. We got rid of this line, so we went down to 1 row. But we went from 2 rows to 1, so we're going to divide by 2. And there you have it. 12 divided by 2 is 6. 36 divided by 2 is 18. I want you to come up with 3 other ways to do that with different numbers of rows and see how you do. Before we go, here is our riddle for the day. Here's what you got to do. Place the numbers 1 through 9, and you can't repeat any numbers, 1 through 9, in the squares below so that every row, this is a row right here, or let me use our shading tool. That's a row, that's a row, that's a row. And every column, that's a column, that's a column, and that's a column. And the diagonals, these 3 and those 3. All of those have to add up to exactly 15. All right, I hope you enjoy working on that riddle. It has been great to see you all today. If you have any questions, don't hesitate to email me at jkamras@rvaschools.net, and I look forward to seeing you all tomorrow. Bye, everybody.